my dear students, class 10. In our last video, we discussed 6 formulae of electricity. So far we remember we discussed how to calculate the equivalent resistance of the resistors connected in series and the equivalent resistance of the resistors connected in parallel. Now let's continue the next formula number 7 under chapter electricity, that is part 2. So first formula we have taken W is equal VQ. Let's remember we have discussed this formula in our formula number 1. Why VQ? Why W is equal to VQ? We have already discussed. You know, in an electric circuit, the circuit is always resistive. It resists the flow or motion of electrons or negative charges because the conductor has its resistance, we have already discussed. And in the circuit we use different appliances or gadgets and they have their own resistance. So the electric circuit is resistive. So what happens? The energy supplied or drawn from the source is continually dissipated or converted to heat energy. That is called the heating effect of electricity. And that effect is applied in heating devices like your geyser, electric heater, oven, and all appliances that generate heat. These are called heating devices. Okay. Now you see the amount of work done due to the flow means displacement of number of charges by the electrical pressure or the potential difference V, the amount of work done is equal to the amount of heat dissipated. The amount of heat energy produced is equal to the amount of work done due to displacement of Q charges by 1 volt potential difference. So that's why we have written W is equal to H equal to VQ, that we have discussed in our formula number 1. This is important. Now come to our next formula, formula number 8. So when we got actually H is equal to VQ. Now you see the H is the amount of heat dissipated in the circuit. Okay. That is called heating effect of electricity. So let us compare. That implies V into IT. V into Q means V into IT. Now you remember the second formula, I is the current, is the amount of charges, negative charges flow per unit time. So from that we can get, IT, Q is equal to IT. We see Q is equal to IT. That we have discussed in our last formula. Let's apply. Okay. So instead of replace Q by IT, now you get VIT. Okay. So H is equal to VIT. So now it is clear, right? Next actually, please come to formula number 9, the same H, VIT that we derived. Now let's apply V is equal to IR because V varies I, V by I is equal to R, okay, and implies V is equal to IR, that is Ohm's law. Okay. Now let's apply here. In place of V, let's write IR. So IR into IT. Now we get I square RT. Okay, I into I square RT. That is called Joule's law of heating. Now the amount of heat depends upon three things, you see: current, resistance and time. Let's define. Let's explain. The amount of heat H is directly proportional to the square of the current for a given resistance. Point number one. Point number two, the amount of heat is directly proportional to the resistance for a given current, and the amount of heat is directly proportional the time for which the energy is drawn from the source. So three factors, they are responsible to determine the amount of heat dissipated in the circuit. Okay. So what are they? The current, resistance and time. So that is called Joule's law of heating, and it is an expected question in the upcoming board examinations. Board examinations. So please come to the next one, 10, formula number 10. Now you see, P stands for power, that you have learnt in class 9. Power is the work done per unit time. The work done per unit time. So we can write P is equal to W by T. Okay. Under W we know VQ. You see W VQ. So let's apply. So we can write VQ by T, and simply you see V into Q by T. Now you see Q by T equal I. Okay, that we have already discussed. Now in place of Q by T, let's write I. So now we got P is equal to VI. Very important. So P is equal to VI. Now come to the next one. So P is equal to VI. That implies, you see, in place of V, let us write IR. Okay, V is equal to IR Ohm's law. Okay, so IR into I. Now we get I square R. That is another formula. P is equal to VI. P is also equal to I square R. So in different situations we have to apply different formulae. So you have to understand the appropriate formula which is applicable for the situation, for the problem situation that demands. Okay. Now you come to the formula number 12, P is equal to VI. That implies another thing, you see, keeping V intact. So I is equal to V by R. You see, by transposition, I is equal to V by R from Ohm's law. So in place of I, let's write V by R. Now we get another formula, P is equal to V square by R. So final result, this is very important. The power is equal to VI is equal to P is also equal to I square R. P is also equal to V square by R. Okay. So this is very, very important. The three formulae you have to remember, and it is easy to remember, and we have derived simply for your easy understanding. Now come to P is equal to VI. So you see the SI unit. SI unit of power is watt, denoted by the symbol capital W. So 1 watt you can write. So V is equal to 1 volt into 1 ampere. So ampere means the SI unit of current. So P is equal to, or 1 watt is equal to 1 VA. This is very important, and this question was asked. Okay. Now you see 1 watt is equal to 1 watt is very very less, is minute. So it is expressed in terms of in kilowatt. 1 kilowatt. 1 kilowatt is 1000 watt. Okay. 1 kilowatt is 1000 watt as per your MKS system. Okay. So 1 kilowatt hour, here our time is here. Now let's expand it. It is 1000 watt into 3600 seconds. That is time, and that is the power. So this is P into T. Okay, so that is the amount of energy. The amount of energy is equal to P, this is P, and into TPT. Okay, so that comes to 3600, 3000, 3 zeros, 2 zeros. Here will be 5 zeros. Okay, 5 zeros. So that will be 36 into 10 to the power 5, or 3.6 into 10 power 6 watt second. Okay, this is important. And 1 kilowatt hour, that is the energy, amount of that is energy, is equal to 3.6 into 10 power 6 joule, because the joule is the unit of work. Okay, so now see, 3.6 in 10 power 6 joule, that is called 1 commercial unit. That is the energy. You see, 1 commercial unit that we purchase from electricity board or electricity supply agency for our payment. And there is a confusion that some students, they say we purchase current, some say we purchase potential differential voltage. No, that is, we purchase electric energy that is consumed in our domestic or different purposes. So that is 1 kilowatt hour. 1 kilowatt hour is 1 unit. So the meter reader says, in this month, so you have consumed 150 units, means 150 kilowatt hour energy you have consumed. Okay, so basing on this, we have taken a problem for clarity, for your clear understanding. So you see, an electric heater of 1500 watt, that is the power, is connected to a source. Source means of energy, that is, so potential difference. The source is the differential pressure, that is the potential difference of 220 volt. So the question was set in the previous year exam. So the candidate is required to find out what rating of fuse wire is to be used in that circuit. Now you see, simply you apply this formula, P is equal to VI, and this is the power and the 1 volt and current, 1 VA. So by transposition, changing the position, we have to find out the current, because means fuse wire for different amperes are available in the market. Okay. Now you see, I is equal to P by V by transposition. So P is given 1500 watt, that is 1500 watt, and that potential difference V is 220 volt. Okay. Now 0 0 cancel. So 150 divided by 2, that is 75, and 20 by 2, 11. Now it comes 6.8 ampere. Now you see why this question was asked. So these ratings of fuse wires are available: 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere. You see 6.8, there is no such fuse wire. So what rating will be used here? That is 10 ampere. You might have seen, in case of your fan, means electric bulb, only 5 ampere or 3 ampere fuse wires are used. But in case of electric heater, geyser of rating 1500 or more, that is 10 ampere. Then next is 15 ampere, that is not given in your book. 15 ampere is used for higher watt of gadgets. Okay. Higher power gadgets, using gadgets means drawing, means consuming more power. Okay. So according to the power, as per the power and the source, we have to calculate what rating of future is to be used. This is an example we have taken for your understanding, and this question was asked in your previous year board examinations. Hope your concept is clear right from formula number 1 to formula number 17 we have discussed in detail. Now basing on these formulae, you have to calculate different numerical problems that are supposed or expected to be set in your upcoming board examination. Thank you for watching. If you like, you may subscribe to watch our series of academic videos and share for the benefit of others. Thank you for watching.